Welcome to our overview of theoretical and experimental probability. So, probability is how likely something is to occur. So, the probability of rolling a dice or picking a number out of a hat or picking a student randomly in a classroom. Those are all probabilities. The outcome is the result of one trial. So, the probability of me winning the lottery. The outcome, I lost the lottery, so that's going to be no probability. Sample space is a set of all possible outcomes, and then the event is any outcome or group of outcomes that could occur from your sample space. So we've got theoretical probability, and that's if all possible outcomes are equally likely to occur, then you can find the theoretical probability by dividing all possible outcomes by the total number of outcomes. So the probability that I'm going to roll a 3 on a number cube, a standard number cube, is going to be, in theory, it should be 1 out of 6. Every 6 times I roll the number cube, I should get a 3 once. That's theoretical. It can be written as a fraction, 1/3. We can convert that to a decimal, which would have to be rounded, 0.33 repeating, or a percent, which is 33 1/3%. Probabilities could range from 0, which is impossible, to 100%, which is it's going to happen. And then we've got our complement to the event. So you think about that theoretical probability of me rolling a 3, which is 1 out of 6. So the complement to that event would be, well, what's the probability that I'm not going to get a 3? That's going to be 5 out of 6. So that's the number of outcomes not in our event, which was picking a 3, which would be 5 over 6. So think about the complement of rolling an even number on a die. So we've got 3 out of 6 even numbers. So the probability of rolling an even number is 3 out of 6. The complement of that, which would mean the probability of not rolling an even number, would also be 3 out of 6. And they should add up to 1 if you think about it. So what is the complement of the event that it rains today? Well, if today's chance of rain is 25%, the complement would be there's a 75% chance it's not going to rain. The sum of the probabilities of an event and its complement should always be 1, or 100%. So odds describe an event by comparing favorable to unfavorable. So find the odds in favor of a number cube landing on a multiple of 4. Well, there's only one number, 4, that is a multiple of 4 on the number cube, a standard number cube, and then there are 5 that aren't 4. So the odds would be 1 to 5, okay? Odds are usually written with that colon between them as opposed to a fraction. Don't confuse odds with probability. They kind of have the same meaning, but the odds are going to be favorable to unfavorable, whereas the probability, whether it's theoretical or experimental, is going to usually be over the total. So it would be 1 out of 6 there. So find the odds against picking a vowel from all letters in the alphabet. So there are 21 consonants, right? So against picking a vowel. So there's 21 to 5, okay? That one's worded a little funny, but again, with odds, so we've got our vowels and our consonants. 5 vowels, 21 consonants. So those would be our odds. 21 to 5 or 5 to 21 based on how you read that problem. But it would not be over the 26 letters in the alphabet, because then we start thinking about probability as opposed to odds. So theoretical probability is always what's happening in your mind. It's what should happen. If in theory, if I play the lottery 10 million times, I should hit the big jackpot once, right? In theory, that would be great. Experimental probability is what actually happens when you're performing the experiment. So I play the lottery, I haven't won. My experimental probability is 0 because I have not hit the lottery. I have not won the lottery. In theory, if I keep playing, I should win eventually. If you think about experimental probability with rolling a number cube, you roll a number cube, let's say you roll a number cube 20 times and you don't get a 5. In theory, you should have rolled a few 5s, but experimentally, because when you've performed that experiment, you have not gotten any 5. So the probability of you rolling a 5 is 0. Now, the thing with experimental probability is the more cases you do, the more trials you run, you should get closer to that theoretical each time. The more experiments you go through. So just remember that when you're talking about probability, experimental versus theoretical. Theoretical, it should happen. Experimental is actually what does happen after you've performed an experiment. Compound probability, so independent events. So let's say I flip a coin and roll a dice. Those are two independent events. One's not going to affect the other. So I could find out the probability of getting a heads on my flip and then a 5 on my spin, or rolling my number cube. So I would take that 1/2 and multiply it by the 1/6, and then the compound probability, which would be the probability that I get a heads and a 5 would be the 1/2 times the 1/6, which gives me 1/12. So I have a 1 in 12 shot of getting a heads on my coin flip and getting a 5 on my rolling of the number cube or the die. Now, dependent events tells us that the first event kind of influences what happens in the second event. So let's say I have 6 colored pencils and 3 of them are green and the other ones are random colors. If I were pulling blindly from those 6 and I want 2 green colored pencils, I pull out the first one. In theory, I have a 1/2 or 3 out of 6 chance of getting a green colored pencil. Now, I pull that green one out, I only have 5 left. So whatever I pick the first time really affects what happens next. Sometimes this is referred to as replacement probability. If I don't put that green back in, now I only have a 2 out of 5 shot of getting another green in that second pull. And so I would multiply that 1/2 by that 2 out of 5 to get the probability 2/10, or 1/5, of getting 2 green colored pencils when I do the experiment twice. Again, that means that the first event affected the second event, often referred to as replacement with or without replacement. And just replacement just means just what it sounds. Do I put that back in? So if you're flipping coins, if you've got 3 quarters and 5 dimes in your pocket and you take 1 coin from your pocket without replacing the coin and you select a second coin, what's the probability of taking a dime and then a quarter? So we've got 5 dimes, so it's 5 out of 8. That's our probability of taking a dime first. And then without replacing that, now I've got 3 out of not 8, but 7, because I have that dime that I already pulled out. So I have that 3 out of 7 probability of my quarters there. So then I would multiply those two together. That is compound probability, and that is going to be a dependent event. Again, we're going to talk about this more in class. This is just kind of a brief conversation to get you thinking about probability. And please don't hesitate to ask questions or even email me if you have any.